Dear ladies and gentlemen, very warm welcome to our second webinar on production of modules and stacks. I'm Stefan Handel. I'm your first contact as a sales manager for all our lithium-ion related projects. Today I'm supported by René.
Welcome also from my side. I am René Wund and I'm from the R&D department of battery machines. And today I will guide you through the technical details of today's topic.
Thank you for your participation. You will get after this webinar automatically an email with the link where this webinar is registered, so you can watch it afterwards as well. Those of you who are not receiving the link or who like to talk to me directly, at the end of this webinar, you will see my contact details. Of course, you can find me also on LinkedIn or via our website. There you can also find my contact details. So today we're going to talk about the second step in the production. Last time we have been talking about the first step, about cell preparation until stacking and all the steps in between. If you have missed this webinar or you did not receive the link, please also contact me again. When you have finished stacking, you need to fix somehow your module. Usually with the three different types of cells, you also have different types of framing solutions. The pouch cells are usually put into smaller frames or cartridges, which are then stacked on top of each other. So the stack looks then similar as with prismatic cells. Cylindric cells are quite different in this aspect. Cylindric cells are usually stacked already in a prepared cell frame, usually made out of plastic, and the same frame is on top and on the bottom side, and finally you press them together. The third version is with prismatic cells. Prismatic cells classically are the stack is put into metal sheets, and these metal sheets are fixed together and compressed if needed. And these metal sheets are completely covering the cell stack on minimum 4 sides, maybe on 5 sides. And you have a compression plate solution on both ends of the stack. We have a question for you. Which kind of cells are you using in your production, or which cells are you intending to use? So we have made a differentiation between two types of the cylindric cells, the classic small ones or the new bigger ones. Then pouch cells, or are you in prismatic cells, smaller ones or bigger ones? And or last but not least, if you are already using or intending to use this plate type longitudinal prismatic cells. You can make a multiple choice as well.
Okay, so now we want to show you a short video about the metal frame compression and welding of the frame. Here you see our machine. When the product arrives on a workpiece carrier, so the components, the battery cells, the compression plates on the sides and the side plates are here in a loosen situation and lifted up to an isolation test first. In this transfer area, there will be the check, and if this is passed, the machine will turn the module into the behind area where the module will now be welded. As a first step, the module is aligned. So this means the terminals are on the bottom side right now, and the level for the terminals are in the same height after this process to secure a very good or very small tolerance. If this is done, the module will be longitudinal compressed. This compression is monitored by force and by length. And after this reaches the target from the recipe, we clamp the module frame sides to the end plates, and then to bring this up then into the welding position for the laser. So you see here all 4 edges are welded right now by a laser welding process. After the laser welding, the module is checked again for high voltage isolation, and after this the module is released back onto the workpiece carrier. As we have the competence at BM Rosendahl for the connection technologies, as for instance the laser welding process, we have also a laboratory at our facility where we can do laser welding and also the analysis. Here you see a picture of a microscopic analysis of this laser welded frame. We can also do other tests like maximum tensile force or macroscopy tests. And yeah, so if there is a question on laser welding, we can help and support you.
Thank you, René. Is an alternative on the same type of modules with prismatic cells, especially for the actually a lot of demanded big BESS modules with big prismatic cells, but not exclusively, not only. The solution with strapping with metal straps is on the market, and one of the main products at the moment. So there you don't have the side sheets anymore. You can save these costs and simply put the stack with the 2 compression plates together and fix them by these metal sheets. In order to have a good industrial solution for continuous production, we also have developed a solution, a machine for you.
So also for this variant of strapping, we have a new machine developed called the BME strap machine. In this machine, we have the chance to produce a module which is here loaded by a robot, also just stacked, but not fixed. So the battery cells and the end plates are loose in this situation. And in the machine, the stack will be aligned, and the robot will position the metal straps into the perfect position. The straps can be open and or closed, and are now yeah. So here you can see right now the controlled process of compression and with a special force over the length. This is same as we had it already in the plate version, and after the straps are positioned and closed, the welding process for resistance welding in this case is done. So every strap will be welded, and after the welds are done, the module is released again, and now the force and the length is now secured by the straps. And this is a very good process combination to secure a process for a good measurement, for reproducible products and a high quality of these modules. So here we see that the module is then picked up by an automatic robot, but it can also be loaded and unloaded by manual means. So as well here, we have also a picture from our laboratory where we can analyze this welding in position of the weld seam, in structure of the metallurgy, and in depth or width of the welding itself.
Thank you, René. Before we come to the news and about the next steps, please answer the second question that we have prepared for you. So if you are active in the production of modules with prismatic cells, please let us know if you are working with metal sheets or already with straps, or also here if you already use both or none of these solutions above. Well, this was the presentation of today. Before we come to the questions and answers, please note that you can meet us and you can see the machine that you saw in the last video, the PME strap. You at the battery show coming up in 2 weeks in Stuttgart from 3rd to 5th of June. You will find us at hall number 10 at the booth A55. And if you have a tight time schedule, please fix a meeting already beforehand with me. The webinar number 3, which will be focusing on the laser welding of bus bars, will be held on the 26th of June, and you will receive a link for registration very soon. So now we can go to the questions and answers. Please feel free to type your questions into the chat, and René and myself, we will try to help you with our answers. So as there are no questions coming in at the moment, I will try to point out once again one of the important points of the 2 solutions that we showed to you. So it's really this, besides our knowledge and the high quality solution and repeatable solution with laser welding, that a stable and repeatable process and a controllable process for this compression is a key factor for the stable quality of these modules produced.
So the first questions are here.
It's coming. Which material do you weld?
So for the welding, we can weld with the laser technology a lot of different materials. In frame welding, we have mostly steel combinations, and in the strap, we have also stainless steel Depends a bit also on the application, which forces are needed over lifetime of the battery. So therefore the material can be adjusted onto the specifications of the application.
So whenever you have any task to combine also difficult versions of metals, please contact us and we will try to find a solution with you. And we have already done quite tricky combinations of metals as well.
So second question is about the forces.
What force is used to compress the modules?
So the forces are also application dependent, but in most of the cases we are around 2 kilowatts up, kilonewtons up to 7 to 8 kilonewton. So it depends a lot also on the battery combination, on the specification of the module.
And what I find important, of course, when you have such a good version of machine with online process monitoring, also for the compression, you can also learn and improve your process. You have to learn to handle the type of cells. Prismatic cells behave also differently depending on which kind of chemistry, even can depend on different producers. The stacking inside of the cathode layers can be solved differently. So you have to learn, and you can learn. You have a monitoring. You see the compression values also afterwards. You can adapt and optimize your process with our equipment.
So because of this learning curve, we know which is currently on the market. We have our machines also, we kept them very flexible. So the 7 kilonewtons is not the end for the compression, but that's now the range. But our machines are equipped with stronger forces for compression.
Next question, if we have a monitoring for the laser process, René.
Yes, that's a good question. When it comes to process developing, to the phase of process developing, we can have also the process monitoring in this field. Most of the time it's for serial production, where you want to know if the weldings are constant or if there are special defects or something went wrong during the welding. So therefore you use a process monitoring system which controls inline the laser welding process by reflection of different radiations. So it's for serial production, we see it necessary. In the development phase, it comes somewhere together with other process parameters.
Next question is really about the strapping. If I'm right, is the tension of the straps, are they also tensioned to the straps? Are they pulled with a defined force? And are these forces, if so, are they adjustable?
Yes, these forces are adjustable. And the tension, it's, I would say, a tension for the beginning, for the assembly. During lifetime, the forces will be much, much higher as the swelling of the battery cells will be additional to the preload of the assembly. So therefore, yes, there will be a tension on the straps. This is monitored by the compression on the one hand side, and on the other hand side, the length of the module will be controlled as well.
And I think here we can say it's about the same as with the compression of the stack, also the tensioning of the straps. We can optimize it together. The line control system will register and give you the chance to make tests and optimizations on your product. And of course, we can also for startup and the testing of any of your most likely new products, install a tension measuring system directly in the module to see the correct behavior during production, but also after the process is completely finished, and then to monitor if the cell stack is still moving and to find the correct parameters on the machine. Next question, jumping back to the welding of the frame. What are the atmospheric conditions for welding? Are specific dew point conditions needed?
Yes, for the welding itself, the surrounding conditions do not have so much impact, but to the laser equipment itself has a dew point which must be to the surroundings condition adjusted, and therefore there is in the choosing of the laser welding equipment, you have to keep an eye on the surrounding conditions. Most of the time we see the complete production shop floor in conditioning phases, so for humidity and temperature.
So meaning that we don't really need a complete closed compartment or conditioned compartment, but a standard modern production site. And of course, I think it's almost logic, but I like to mention it, as with many other processes, you should bring raw materials like the metal sheets into the inside of your factory when they are stored outside or somewhere 24 hours prior to their use in the line, especially at cold times or northern regions, or when you are situated in some regions with extreme humidity situations. So that automatically the raw materials that you like to use are getting stabilized in the surrounding atmosphere.
Yeah. So for back coming to the laser equipment is held on a certain temperature to be above this dew point, because this was the question, and not to have any effects on the optical system in the laser equipment. Yeah, in the cabin.
Specific question on the stack, I would say, but how the stacks then behave under the final compression. Which material would you recommend placing between the cells to accommodate cell swelling? I mean, it's a question for the real product design.
Really? It depends a lot on the application. Compression pads are most of the time also needed to reduce tolerances during lifetime and to hold up a certain force on the module. So with the BME strap we showed before, there is no really need to compensate the tolerances or the swelling forces, because we can control by the compression and by the length. Mostly isolation foils are in between, additionally to the already wrapped and isolated battery cells.
Thank you, René. Now there is a detailed question about the welding of the straps, so the resistance welding that you have shown. How much space do you have? Do you leave to assemble the metal strap on the module, or maybe it is welded on the module?
It is an overlap welding situation for the straps, so we weld together the two straps. Of course, the compression bed is on the ends of the module should be designed that the straps can be pressed against the module, and the module can get the force we need to bring up the the good welding, we need also a resistance from the module. So this is on the one hand side a design thing on the end plates, but we don't really want to weld it in this machine to the module end plate. Of course, this can be also another design which is possible with our machine, I would say.
We only weld the two the overlaps of the two straps together, not the straps to the
end plate.
To the end plate.
Yeah.
You made two steps during the compression phase of a prismatic cell module to the elastic behavior of cells or another component?
So this can be done in our machine. So as we have the full control over every movement, we can also rest down. Of course, this will have an impact on cycle time. In the demonstration, we just have one compression phase.
It's a very good point, and it's feasible to also have this, let's say, more complex compression process or multiple step compression process realized on our equipment. Are straps bended preliminary in the machine?
Right now, as we showed, we have automatic loading also for the straps. So the open straps are pre-bent. Also, if you have a closed strap, so a ring which is already closed, this is pre-bent. Right now we have this solution. It's a pre-process, I would say, to be sure that every bending, every isolation as well is in right position. So this is a pre-process for our machine.
What material do you recommend for the front walls of the module if required?
I think for the front walls, this means the compression pad or the end plates. Yes. So let's say if the forces are, it depends a lot on the forces you want to generate. The end plates can be made of bended steel. It can be also aluminum or full plates, and also casted aluminum plates. So this depends a lot on the product design, I would say.
Thank you. Next question. We will hurry up to cover all the questions which are here right now. What are the advantages of the metal straps compared to the side plate? How big is the approximate cost saving? Very good question.
Very good question.
Really, it has to be analyzed in detail. I'm showing you here again this sample module with straps. So, of course, you really save all this volume of metal sheet. In addition, because below the metal sheet, you will also have the requirement to have insulation sheets. So this can be an additional saving. Of course, you are looking to save costs on a really, let's say, small steps, but in total, this can, in a serial production, will also make a good difference.
So I would also say that it's not only a cost reduction, also a weight reduction. For some applications, weight is also very important. So it can also be there a good solution to reduce maybe CO2 footprints.
What do you do against the sweat splashes? How do you clean the hold down devices?
So, of course, there is some maintenance on the electrodes which has to be done. More or less for one shift, the electrodes should withstand these processes. So the maintenance should be very low during the shifts. Yes, there is to have a perfect quality. You should have an eye on the electrodes or on the spattens for a good process.
So perfect. We have tried to answer all your questions. Thanks for this interesting participation, and that adds a lot to this webinar. You will receive afterwards here down in this webinar also my contact details, and then hope to see you at the battery show in Stuttgart and or at the webinar number 3, end of June. Thank you, René.
So thank you for joining.
Bye-bye.
Have a good day. Bye-bye.
Good day.